Hello students, this is ISI M.MATH solution paper. This year we have chosen to solve this 2017 paper. Actually, this is subjective, and the first question is, if an belongs to R such that summation of an equal to infinity, so and the summation of an equal to a belongs to R, m tends to infinity, an positive, max an is 0, so that this is infinity. So this is a real analysis based question. So we have this representation, we use this thing, an plus mod of an is 2. Now so for any c there exists m0 for that, for all values of m greater than equal to m0. So if this thing happens, then summation of an minus a is less than 1, and summation of mod an may be greater than 2c plus mod a plus 1. So if this thing goes, then m greater than equal to m0. So we have an plus equal to half summation of an half mod of an. So this is equal to 1 by 2 a 1 by 2 summation of an minus a plus half mod of summation of a. Now this thing is greater than equal to half summation of an minus half of mod a minus half summation of an minus a, and that is greater than half 2c plus mod a plus 1. I'm just simplifying it, mod a by 2 minus half, so which will be equal to c. So now for any c which is positive, so there exists a m0 for which m greater than equal to m0. So now we can say this is an plus greater than c. So in other words, an positive is infinity. So it goes till this. So that's the answer to the first question. Let's move to the next one. This one is of again a real analysis based question. So this says E equal to xyz, RQ xyz greater than 0, xy plus yz plus zx equal to 1. Prove that there exists ABC such that ABC greater than equal to xyz. Okay. So AMGM inequality will be useful here. If n greater than equal to 1, then A1, A2 dot 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 AN, that is greater than equal to 0. So A1, A2 dot 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 AN whole by 1 by AN. So this is n by n. So let n equal to 3. So A1 equal to simply xy, A2 equal to yz, A3 equal to xz. In that way we can proceed. So A1, A2, A3 whole to the power 1 by 3 is xyz 2 by 3, which is less than equal to the sum or the AM, and that is equal to xy plus yz taking 2 together plus zx by 3, which is equal to 1/3. Now for any xyz in this, what we can do? So we have, like, we can write xyz less than equal to 1 by 3 to the power 3 by 2. So let's take this ABC now. So 1 by root 3, so 3 values will be there. So again a 1 by root 3 that belongs to E. So ABC simply we can write greater than equal to XYZ. So obviously for any XYZ belongs to E, the answer is